Section 7.5. Breaking down the process subproblem. We need a name for our function that implements the process step. We'll call it getSpellingSuggestions because it will be responsible for returning the spelling suggestions for what the user typed. It certainly needs to take the user's misspelled word as an argument, or it wouldn't have access to it. Pause here for a second, though. Do you think this function needs any additional parameters? Answer: it does. Somehow the function needs to know which strings are real words in English. For example, it has to know about the words successful, thorough, acceptable, and thousands of other English words. We could do that in a couple of ways. We could pass a list or Python dictionary of real words as a parameter. Or we could pass the name of a file that contains all the real words as a parameter. When you're designing your functions, you'll need to make similar decisions, focused on the inputs that the function needs to do its work, and the return value that we need when it's done. In addition to the misspelled word, we're going to have our function take a parameter giving the name of a file that contains the list of valid words. There will be one valid word per line of this file. In the resources for this book, we've included one sample word list file called wordlist.txt that you can use. We found a list of free dictionary words online with a simple internet search. What do we need to do for this process step? We can think of 4 subtasks. This is more problem decomposition. Those subtasks are as follows. Get a list of words from the word list file. A file of words is a good start, but it's more convenient to have the words inside a Python list. That way we can easily determine if a string is a valid word. We'll name this function createWordList. Generate a list of all possible words from the user's string. We need to delete a letter, insert a letter, or change one letter to another letter. This is going to generate many strings, some of which are real words and others that aren't real words. For example, from the string successful, it would generate the real word successful, but also the strings xsuccessful, successful, and successful, which are clearly not real words. But that's okay. For now, we just want to generate every possible word so that we don't miss any. We'll name this function allPossibleWords. Using the list of all possible words, generate a list of only the real words. This is the step where we prune our full list of potential words down to those words that actually exist in English. We'll name this function allRealWords. Return a list of the unique words. Why unique? We don't want to return the same spelling suggestion twice, even though there may be 2 or more ways to arrive at that spelling suggestion from the user's string. For example, to fix the word successful, there are 2 ways to do it. We can add the missing C before the C that's already there, or we can add the C before the E. Both result in the correctly spelled word successful, but we only want to maintain that word once. If we were to split out that final subtask, obtaining a list of unique words, into its own function, we'd call it something like unique words or only unique words. While we could split out that subtask, and you'd be justified in doing so, we've decided to keep it as part of the getSpellingSuggestions function. The reason is that in Python, it ends up being just one line of code to remove duplicates from a list. For expediency, we're telling you this now. But again, this would be a perfectly good subtask if you were doing this top-down design on your own. Multiple ways to break down problems. There's no single correct way to do a top-down design and no single correct way to decompose problems into subproblems. For example, you may have been surprised that we decided to first generate all possible words, including fake ones that aren't actually English words, and then prune that to the list of actual English words. Why not just check each possible word first, and only add it to our list if it's a real word? We certainly could have done it that way too. If you had this alternate decomposition in mind, or we've piqued your curiosity, we encourage you to try this alternate design on your own after you've finished with the chapter. There's also no shame in trying a top-down design and then abandoning it if the design isn't working out. What might it mean for the design to not work out? Well, maybe you're finding it difficult to break up large functions into distinct subproblems. Or maybe you're getting dozens of tiny functions and starting to worry that your functions are too specific and not solving general problems. Or maybe you're having to pass around many parameters, perhaps some of which are only there to be passed further and further until finally a function needs them. Or maybe you just want to play out an alternate top-down design to see how it goes. We encourage experimentation at the design phase before you settle on a final design for the code. In this experimentation, you'd try different possible functions and different inputs and outputs for functions. For example, earlier we debated whether the getSpellingSuggestions function should take a name of a file containing real words or a list, or dictionary, containing real words. Both options would be worth considering during your design phase. That leaves us with 3 subtasks we need to solve. We're going to do our top-down design on these shortly. But first, let's take stock of where we are right now. See Figure 7.3.
Figure 7.3. Functions diagram showing the 3 subtasks of Get Spelling Suggestions.
Section 7.5.1, getting the list of words from the word list file. The function for this task is create word list. It will take one parameter, which is the name of the word list file, and will return the list of words from that file. Do we need any further top-down design on this function? Let's imagine we thought the answer was yes. What subtasks could we split out? We could imagine the tasks of opening the file, reading its contents, and closing the file. But opening the file, as we learned in Chapter 5, Section 5.1.4, is done by just calling Python's open function. Similarly, closing the file is done by just calling Python's close function. What about reading the words from the file? That doesn't sound much different from reading the lines of the CSV file in Chapter 5, Section 5.1.4. So we feel justified in leaving this function alone, without any further subtask splitting. Section 7.5.2, generating the list of all possible words. The function for this task is all possible words, which will take one parameter giving us the string for which we want to provide spelling suggestions. It will return the list of all possible words that can be obtained by adding one letter, deleting one letter, or changing one letter. Adding one letter, deleting one letter, and changing one letter are 3 distinct types of tasks. Moreover, they don't strike us as particularly simple tasks. They're going to involve some sort of loop over the letters in the user's string. Aha! Looks like we have some further top-down design to do on this one. In particular, we're going to split 3 subtasks out of this function. Add letter. This function will take a string parameter and return a list of all strings that can be obtained by adding one letter anywhere in the word. Delete letter. This function will take a string parameter and return a list of all strings that can be obtained by deleting one letter. Change letter. This function will take a string parameter and return a list of all strings that can be obtained by changing one letter. Table 7.2 provides what we expect each function will return for 2 different input strings. For both add letter and change letter, a large number of strings are returned because they will consider adding or changing every letter in English in every location in the input string.
Table 7.2. Examples of the add letter, delete letter, and change letter function.
As usual, it's important to think through whether we need to split out further subtasks from these 3 functions. However, given that the pattern we expect to see is just a loop through the letters, we'd be comfortable pushing forward here and revisiting our top-down design if our assumption proves to be incorrect. For now, we can tell you that we'll be just fine without any further splitting. Knowing when to stop dividing into subtasks. In general, knowing when to stop breaking a task into smaller subtasks is more art than science. It takes practice designing programs to get intuition about where to stop. Many experienced developers often pause for each subtask and consider how complex it is to program and sketch the steps of the function out in their mind. If the solution isn't straightforward, they often choose to divide it into more steps. But we don't expect you to be able to do this yet. Some companies put out guidelines to encourage simple functions by suggesting limits on the number of lines permitted, for example, no more than 12 lines. But many feel the limit should be on the complexity more so than the length, although length and complexity are certainly related. When you're just getting started, a decent proxy then is to limit the number of lines per function to something like 12 to 20. If you later find that a function ends up being just a single line, it's still a subtask, but may not deserve its own function. Sometimes, it's okay to keep a short function though if it's called many times by different functions or helps simplify the calling function. It's okay to get this wrong when you're first practicing. We certainly have. Sometimes a subtask seems like it'll make a simple function, only to end up being much more difficult than expected. In cases like that, you know to just subdivide it more. Likewise, we've had functions that were a single line, and if they were used commonly, or made the calling function simpler to understand, we just kept that line as a function. Section 7.5.3, generating the list of all real words. The function for this task is all real words. It will take 2 parameters, the list of real words and the list of all possible words. It will return a list consisting of only the real words from the full list of possible words. The code for this function would involve going through the list of possible words and checking whether each one shows up in the list of real words. As this task is a small, well-defined task that won't yield a lot of code, we're comfortable leaving this function alone without any further splitting.